Hey guys, welcome to the class. Today we would be talking about replica sets. So pods are the basic building blocks in Kubernetes, but if we deploy them directly, all we get is a single vulnerable pod. We don't get any self-healing or scalability. So if that pod fails, it's game over. Because of this, we always deploy pods via higher level objects like replica sets and deployments. These bring all the goodness of self-healing, scalability, and more. So you may hear people use the term replication controller and replica sets interchangeably. This is because they do the same thing. However, replica sets are the future and replication controllers are being phased out. So one final thing before moving on, more often than not, you are not going to deploy your application wide deployments rather than replica sets. However, deployments build on top of replica sets, so it's vital that you understand what we are going to cover in this lecture. We will we will have a theoretical part discussed in this chapter. So let's start out with the high level stuff. Pods wrap, you know, around containers and bring a bunch of benefits: co-location, shared volume, simple networking, secrets, and more. In a similar way, replica sets wraps around pods and bring host of benefits. Before getting into the benefits, we need to make one thing about replica sets crystal clear. It is one-to-one relationship between replica set and particular pod. As an example, assume you have a microservice app comprising three services. You will more likely build this so each service is contained within its own pod. This will give you three pods, one for each service. To manage these three pods, you will need three replica sets. That's because a single replica set cannot manage more than one type of pod. So if we look, or get into deeper, that we will get to know that in the basics, a replica set defines two important things. One, the pod template. Two, the desired number of replicas. The pod template tells the replica set what type of pods to deploy. Things like container image, network ports, and even labels. The desired number of replica tells the replica sets how many of these pods to deploy. Now, as an example, you might need 4 instances of a particular front-end web pod constantly running. You would use a replica set to accomplish this. Well, that's right, there is the basics of replica sets. They may they make sure we always have the right number of the right pod. Let's get into a bit of detail. It's all about the state. It is critical that you understand three concepts that are fundamental to everything about Kubernetes and therefore fundamental to replica sets. One is desired state, second is current state, and third is declarative model. Desired state is what you want, current state is what you have got. The aim of the game is for the two to match. Current state should always match desired state. A declarative model lets you describe your desired state without having to get into the details of how to get there. Now, let's talk a bit about declarative model. We have got two competing models, the declarative model and the imperative model. Declarative models are all about describing the end goal. Imperative models are all about list of commands that will get you to an end goal. Let's look into an example. Assume you have got an application with two services, front end and back end. You have configured things so that you have a pod template for the front end service and separate pod template for the back end service. To meet expected demand, you always need 5 instances of the front end pod and 2 instances of the back end pod. Taking the declarative approach, you create a configuration file that describes your front end and back end pods. You also declare that you always need 5 front end pods and 2 back end pods. Simple. you give that file to Kubernetes and sit back while Kubernetes does all the heavy lifting. But it doesn't stop there because you have told Kubernetes what your desired state is. Kubernetes watches the cluster and automatically recovers from failures. The opposite of the declarative model is the imperative model. In the imperative model, there is no concept of the desired state. Instead, you write a script with all the steps and commands required to pull the front end and back end images, and then to create 5 front end containers and 2 back end containers. And you have to care about details such as which container runtime you are using. The commands to start containers are different from the commands to start RKT containers, etc. This end up being a lot more work, a lot more error prone, and because it is not declaring a desired state, there is no self-healing. Kubernetes supports both model, but it strongly prefers the declarative model. You should only use the imperative model in times of absolute emergency. Now, fundamental to all this are background reconciliation loops. Now, replica sets implement a background reconciliation loop that is constantly monitoring the cluster. It's checking to see if a current state matches desired state. If it doesn't, it wakes the control plane, and Kubernetes takes steps to fix the situation. Sorry. But it's not just the failure scenario. But before that, if the two diverge, maybe desired state is 10 replica. Now, let me quickly give you an example. To be crystal clear, Kubernetes is constantly striving for harmony between current state and desired state. If the two diverge, maybe desired state is 10 replicas, but only 8 are running, Kubernetes switches to red alert, orders the control plane to battle situation, and brings up 2 more replicas. Yeah. And the best part, it does it all without paging you a silly message early in the morning. But it's not just failure scenarios. This very same reconciliation loops allow us to scale up and down. For example, imagine scaling an application from 3 pod replicas to 5. To do this, we post an updated version of the replica sets manifest file to the API server, where this gets registered as the application new desired state. Then the next time the reconciliation loop runs, it notices that desired state is 5 and current state is only 3, and the same routine is followed. Kubernetes calls red alert and the control plane spins up 2 more replicas. So it would be fair to say that the desired state is the reason AR at the Kubernetes, and the reconciliation loop is the beating heart of Kubernetes. So with that, I'm taking a pause here. In the next lecture, we would be talking about more in depth, and we will start with replica sets manifest files. Thank you.